now. All right, guys, can you hear me clearly? Thumbs
Yes.
up if you're good. All right, so if you look at our outline here for today, our essential question is, how do I use product of powers of exponents to simplify expressions? With our outline, we have some vocabulary that we're going to start with. We're going to talk about a new idea called the product of powers, and there's going to be two ways that we can actually solve this. You'll have a little bit of time for independent practice and hopefully some group practice in which you guys can collaborate a little bit. So if you look at the vocabulary here, we have the first word is a power. The power is composed of the base and the exponent. So could I have a volunteer to please read what I just circled there out loud? Go ahead, Michael.
That's 8 to the third power.
8 to the third power. Very good. Thank you. The next word we have is the word base. This is the number that is being multiplied in our case. So the 8 up here is going to be our base. And lastly, our exponent. Our exponent is how many times we're going to use the base as a factor. Factor is another way of thinking about the operation of multiplication in our case here. Do we have any questions?
No.
We're okay? All right. I'm going to continue on here. So with our new idea called the product of a power, we're going to use some new methods to simplify our expressions. So I have in this first problem here, 7 to the third power times 7 to the fifth power. Now, when we look at this problem, there's two ways that we could do this. There's a shortcut method that we're going to learn, but we want to learn it the longer way at first so we have an idea as to what we're doing. So if I looked at 7 to the third power, how could I expand that out? Meredith.
7 times 7 times 7.
7 times 7 times 7. Very good. And how about 7 to the fifth power? How would I do that one? Another volunteer? Go ahead, Jess.
7 times 7 times 7 times 7 times 7.
Good. So I have 7, how many times listed here? Go ahead, Jess.
8.
8 times. So 7 to the 8th power is my simplified answer in this case. But if we were to look at the original problem, does anybody see a shortcut in which I could do something different instead of expanding it out? Michael.
Yes, so you have 7 to the third and 7 to the fifth, and 3 plus 5 is 8.
Yeah, so you're taking, I'm going to highlight this here, I'm going to zoom in a little bit for you. Oop. I'm going to take my exponents, and I can just add them, like you said. So I'm going to do 3 plus 5 to get 8. And then I will have my base the same, so I have 7 to the 8th power. Very good. Are there any questions with that first problem?
Nope.
All right, now if you see on the right-hand side of our screen here, there are some characteristics of the product of a power. So if I'm looking for certain characteristics, what's one thing that must be true about our bases for this to happen, do you think? Meredith.
They have to be the same.
Yeah, the same bases. So the bases have to be the same. Very good. And then what was our shortcut that we said? What could we do with their exponents? Michael.
You have to add them.
Yeah, add exponents. Very good. So let's take a look here at our second problem. If I have x to the fourth and x to the sixth, what would be my simplified answer? Go ahead, Meredith.
X to the 10th.
X to the 10th power. Does everyone agree with that?
Yeah.
Good. All right, and let's look at this last problem down here. Y to the third times x to the sixth. Can I do anything to this problem? No, we're all shaking our heads. Can someone explain why we cannot simplify this with a raised hand? Go ahead, Jess.
The bases are not the same.
Yeah, I'm going to put different bases. There you go. Someone's picking up some wind out there.
Yeah.
So how are we feeling with these three problems? Thumbs up if you're feeling pretty confident. Thumbs down if you're a little struggling at all. Thumbs in the middle.
Good.
All right, so it looks like most people are doing pretty good. All right. So what we call this with the product of a power in terms of our math terms. So the product rule tells us that when we multiply two powers that have the same base, you can add the exponents. So adding the exponents is just our shortcut method here. So this is going to be your independent practice here. So I'm going to have 2 volunteers actually show their work on their own whiteboards here. So Jess, you said you would like to volunteer for the first one, I believe. So I'm going to stop sharing my screen so that you can share your screen, and I will help you with what the problem is, all right?
Yeah.
Okay, so I'm going to stop sharing. You can pull yours up.
All right, give me 1 second here. Okay. Whoops.
There we go.
Okay. So it was
It was x to the 4th
x to
times
the
x
4th
times x to the 3rd.
to the 3rd.
All
Okay.
right.
So basically, we can do our shortcut, and we can do 4 plus 3, which equals 7. So we have x to the 7th power.
And before we move on, why can you do the addition part? What is true about their bases?
If the bases are the same, you can add the exponents together.
Very good, thank you. All right. So we have our second example. Do I have another volunteer that would like to try the second one? Meredith, you want to try that one out?
Yep, I'll do it, but I don't remember the problem.
All right, I will help you out with that one. So you click on the little share button.
Wait. Share.
And it's the iPad. There you go.
There we go.
All right, so the problem is 8 to the negative 6th times 8 to the 9th. So this is a little bit different than what we've done before. We haven't dealt with any negative exponents.
Plus 8 to the negative to the 9th.
Correct. And you want to change that sign in the middle to a multiplication.
Oh no.
You're okay with that?
Yeah.
Okay.
So they're the same base, so we can add them or multiply them. And then negative 6 plus 9 is 3. So you have 8 to the 3rd.
Very good. So even though the exponent is negative, you still treat it as if it's a normal operation. You would just treat it as negative 6 plus 9 in that case to get 8 to the 3rd. So thank you very much. So if you want to unshare that, you guys are doing well. Mike, do you have any questions from those 2 examples?
No, I think I'm good.
Okay. So what I'm going to do next is I'm going to put you guys into a breakout room. And in that breakout room, I'm going to have you 3 collaborate on 2 more problems in which you can work together. I will be in that breakout room, so if you have questions with that, I will be there for assistance. But I would like you to see if you can challenge yourself with these 2 problems. So I'm going to put you guys into the breakout room. So, oops. I'm going to close. All right, so you should have a message popping up that's saying that you can join it. Is that correct? Looks like you guys are joining that. Are we all in the breakout room now?
Yeah.
Okay, so I'm going to share the challenge with you guys here. Should be on your screen right now.
Yeah.
Okay, there are 2 problems. So you have 6x to the 3rd times 2x to the 4th as the first problem, and the second problem is x to the 4th, y to the 5th times x to the 7th, y to the negative 3rd. So why don't you guys kind of discuss this a little bit? If someone wants to take the lead on the first one and they could show their work, you can do that. You just have to let me know if you'd like me to stop sharing the problems before you write those down, okay? So do I have a volunteer that wants to try the first one?
I can do it.
You want to do it, Jess? And then Mike, maybe you can try the second one.
Okay.
Sure.
Jess, would you like me to stop sharing my screen?
Yeah.
Okay, so you're going to bring your screen up? Okay.
Yeah.
Okay, go ahead. You can share yours if you'd like.
Okay. So for this problem, we have the same base, so we can keep those, which that means that we can add the exponents.
Mm-hmm.
So oops. So, what is happening? Nope, just, okay. So we have 3 plus, whoops. No, stop it.
Technology at its finest.
Yeah, okay, sorry about that. Anyway, 3 plus 4 is 7 as the exponent.
Correct.
And we can multiply the 6 and the 2, so then we have 12x to the 7th power.
Good. So what you're essentially doing there is you recognize that you have the same base. And do we remember what we call the 6 and the 2 out front? There was that special vocab word. You might remember it. Mike?
Coefficients?
Coefficients, yes. So the coefficients you can just multiply like you normally would with two numbers. So you have 12x to the 7th. Very good. Is there a second volunteer for the other one? Mike, you want to try that one?
Okay.
Okay.
Okay, if I share my screen.
You may.
Cool. Okay, and what was our problem again?
It is x to the 4th, y to the 5th.
On my screen's a little x to the 4. Oh, goodness. Y to the 5th.
Yep, times
Mm-hmm.
x to the 7th, y to the negative 3rd.
Okay.
Good. So you can take us through your steps?
Sure thing. So like before, we have the same bases. We have the two x's and the two y's.
Mm-hmm.
So I'll start with the x's. So you have 4 plus 7 gives you 11. And then you have 5 plus negative 3 gives you 2. And since we have the same bases, we could just add them together. So then the answer would be x to the 11, y to the 2.
Good. Meredith or Jess, you have any questions with those two? I know we have not done anything with two variables, but are there any questions with that?
No.
Okay, very good. So Mike, if you can unshare yours, I'm going to bring up the last page of our notes here for you guys. I'm going to ask you to leave the breakout room, please.
Okay.
Okay. Have everyone back there?
Yep.
All right, I'm going to share the last page here with you guys. That comes up. So all I have for you guys is that your homework is going to be numbers 1 through 20 odd, and I want to leave you with one final question to help you guys out. So how do we solve a problem with the product of powers? What are the steps that need to be in place for this to happen? Meredith.
First, you check to see if they have the same base.
Correct?
And then if they have the same base, you know that you can add the exponents.
Very good.
Yeah.
Does anybody else have any questions before we end class? We're all right. So if you have questions, please just let me know. You can email me or you can check the office hours. But if you have questions, just let me know, all right? Thanks, guys.
Thank you.